quick little tour, show you some of the electronic controls that we've set up to control the train here. So we'll start here with our Arduino Microcontroller. So the two goals of the layout were realistic operation and ability for kids to operate it easily and safely. And by using a microcontroller that allows us to do both those, allows us to do slow speed operations reliably, and then with the addition of some sensors to control the behavior of the train, so that it keeps kids from running it off the end of the tracks or from throwing the switches while the trains are on there. The next piece of this puzzle is a motor controller shield, which plugs on top of the Arduino. This is a kit sold by Adafruit Industries, and it allows us to apply pulse width modulation to the tracks to operate the train. Allows us to run it at very slow speeds without it stalling, and it's very handy. This is actually kind of overkill because this can control up to 4 DC motors at once, but we just need to control one for our train. And you can see I'm also using Ethernet cable to tie into the layout just to make it easier to connect, and part of the connections come in here, into the board here. And as you can see, the stackable shield just fits right on top of the Arduino, and it allows all the input-output pins and the 5 volts and grounds to be pulled up to the board so they can be all accessed. The next piece of the system here is a proto board that's just allowing me to bring in 8 more lines via the LAN cable. And it's kind of a stopgap measure, but it's going to allow me to get these connections together easily. And again, that fits right on top of the board like that. Okay, the final piece for this stack is a circuit board that I made, which unfortunately is not operating too well, but you can see I have a basic layout of the tracks here, and the idea is to give them indication of which spurs the throwouts are lined up to. So we've got some throttle indication. I'm doing this using a 16-channel multiplexer, and probably the neatest function on this board, which I'll show you more later, is that I can hook the Wii nunchuck controller right into it as well. And so that's the top of this stack. Now, in addition to controlling the train, I also wanted to have some sound. Adafruit Industry also manufactures a they call it the Wave Shield, which allows you to play 8-bit sound mono off of an SD card file. Unfortunately, between the motor controller and this, there aren't enough pins on the Arduino to run them both at the same time, and so just as an interim gap to get this ready for the model logging conference, I decided to go ahead and get a second Arduino to power this board, and then to teach the 2 Arduinos to talk to each other to let them know when the sound goes. So these are going to stack together. Without bending any pins. And then I'm pulling over power and the transmit receive lines from the other Arduino so that they can talk to each other using serial communications. Okay, and the final piece of this puzzle was I wanted to have it so that somebody coming up to look at it could press a button and have it run. And again, what I've got is just another proto shield with a lighted momentary contact button from SparkFun, and put a little sign on it so that people can see. And so that pretty much completes what I've been calling my stack. It's kind of a kludge, but just to get it running for this conference, it worked well for rapid prototyping. Okay, so all that's left is to plug this all in. So I've got 12 volts coming into the back of the board. I've got a 5-volt regulator on the underside, which provides power to the Arduino. The 12 volt goes to the motor controller, which is then pulse width modulated, sent back to the board to control the train. And I have an external speaker up on top of the layout to provide the mill sounds. Okay, and all that's left is to see if it works. So pressing the button starts the train moving at a very slow and realistic speed. Also starts the audio track, which is about 2.5 minutes long, which is actual sounds from the mill. I recorded one day when I went down there. And this allowed the train to move back and forth for about 2.5 minutes, and then it would stop and wait for the next person to come by and take a look at it. It's kind of slapped together all at the last minute for the show, but it worked very well, and people were quite impressed by it. Okay, I should probably tell you a little bit about the underside of the boards. There are photocells underneath each of the switches and at the end of each spur to keep the train from running off the end or from them throwing the switches while the train's on top of it. That was a common problem with the kids. Underneath the loading shed provides a little bit of a problem for the photocells because it's kind of shaded from the light. And so what I did was put in an infrared emitter and detector pair in a similar manner as the cells, and so that that can detect the presence of a car in the dark and stop the train before it hits the edge of the layout there. All that is done through a 8-bit analog multiplexer and brought out to the Arduino on just 3 pins, which was kind of a neat thing to learn about. The throwouts, I've put the details about those in another video, but it's a circuit that was designed by Ken Stapleton, which operates the Atlas under-table remotes. Those are operated by 12 volts, and I'm using relays to take the 5-volt signal from the microcontroller and to switch those, and those have been working remarkably well. Okay, so I kind of documented how we were for the Model Loggers Congress. I did mention, however, this is a switching puzzle, and if you've seen my other videos, you've seen how you have to operate the train to solve the switching puzzle. And I also mentioned that there's a Wii nunchuck control, so I'm going to go ahead and slide this in here. And so the neat thing about this Wii is it operates on the 2-wire interface, or the I2C, and it allows us to have the XY joystick control and 2 momentary buttons, all coming in through just 2 lines on the Arduino. And so what I've done is the X and the Y, move the train back and forth. And of course I've programmed this to give some realistic acceleration, deceleration, and then I also program the maximum speed of the train. And then I've got it set up for the Y-axis of the joystick to operate the turnouts. And you can hear those switching. I don't think you can see them on the video. And so that provides a very simple interface that even a kid can use to run the train. And then coupled with the programming, the operation characteristics allows for very easy and realistic train operation. So again, this was Ken. I hope you enjoyed this brief tour of the electronics at Dawson Station. I hope if nothing else this has given you inspiration to go and get an Arduino and play around with it. Learn what you can do. A lot of amazing things. It's a lot of fun. Thanks for watching.